Welcome to java-success.com. In this video, I'm going to go through high-level Java architecture interview questions and answers. So if you go to 500 plus Java interview question and answer, under that you will have a category called memory jogger. So this is under memory jogger because before going to an interview, you need to brush up on the architectures that you had worked on. In most interviews, you will be asked to describe the architecture that you had worked recently, and then you will be drilled down on questions like what technologies were used, what frameworks were used, why a particular style was used over the other, pros and cons of particular approach, and so on. So under memory jogger, if you click Java architecture interview question and answers with integration styles, and this symbol diamond means is one of the FAQ type questions. At times you will be asked to draw some architectural diagrams on a whiteboard, and then you will be quizzed with follow-up questions. Okay, let's look at question 1. What are the different application integration styles? On a high level, there are 4 different styles. One is a shared database, batch file transfer, invoking remote procedure RPC calls, and then exchanging asynchronous messages over message-oriented middleware. Let's click on this and expand this. This depicts different styles of integration. Firstly, number of different applications will be sharing the same data. So for example, application 1 will be a customer details application. Application 2 might be an order placement application. So the application 1 will be storing new customer data and updating customer information and so on. And application 2 will be reading that customer data to place orders. The second approach, application 1 will have its own database, application 2 will have its own data. And application 1 say it's about customer data, and that will be stored in the database here. And application 2 is order placement application, which needs customer details. So as far as the customer details are concerned, this might be the source of truth. It is an important term. So when you have the data copied into multiple systems, one system has to act as a source of truth. So in this case, this will be the source of truth. And there will be a batch process that will be extracting data out of this database and putting it into data feeds. Data feeds are nothing but comma separated or tab delimited files. And this will be happening like overnight. Every night it will be a scheduled job by the control M that will be producing the feed files, and then they will be put into the staging table, and then it will be loaded from the staging table into application 2 database. So basically the same data is duplicated, but in here it's only a read-only mode, and all the modification has to happen in the source of truth. The third approach of integration is using RPC, remote procedure calls. There are different approaches. You can make RMI, COBA call, and web service calls. And web services are more popular, and RESTful web service is more popular than the SOAP-based web service due to its simplicity. The fourth approach is message-oriented middleware. In the message-oriented middleware, the application 1 and application 2 are loosely coupled. They don't have to know about each other. All they have to know is the location of the message-oriented middleware and what topic or queue to publish the message to or subscribe the message from. The application 1 will be publishing customer messages to the message-oriented middleware to a particular queue or topic. Queue is for one-to-one, and topic is if there are more than one subscribers. And application 2 will be subscribing to customer data, and when the data is present, it will be getting asynchronously, it will be receiving the data and then processing them into the database. Next, how does a Java application integrate with other systems? There are different protocols like HTTP, HTTPS, SOAP, RMI, FTP, TCP, and other proprietary protocols. JE is typically a 3-tier or a multi-tier system. A multi-tier means you'll have multiple middle tiers here, or it is known as the N-tier. A typical JE, Java Enterprise Edition application, will have a client tier, which is normally a web browser. Then you will have a middle tier and a data tier. In the middle tier, the web application will be hosted on an application server like JBoss, WebCMQ, WebLogic, etc., or Tomcat. And this application, the whole application will be packaged as a WAR file, which is a web archive file, or an EAR file, enterprise archive file. And from the client tier, you'll be making HTTP call, or you can make a SOAP call. SOAP will be over HTTP. So a basic web application make a HTTP call over the network. HTTP sits on top of TCP/IP, which is a low-level protocol. And you'll have a web layer, which is protocol dependent. So it will be knowing how to communicate HTTP protocol. So you'll be receiving the messages via the HTTP protocol. And you will have servlets, JSPs, HTML, CSS, and web-based frameworks like Spring MVC, Struts to process the request. Then you will have a business logic layer. The purpose of the business logic layer is to encompass the business logic. And then you'll have a data access layer, is responsible for getting data. So the data access layer will be using JDBC or JPA to talk to a database and get the data, or it can use web service frameworks to talk to a web service endpoint. It could be a JAX WS or JAX RS. And then it can also talk to message-oriented middleware via the JMS API, which is an interface. And then you will have the JMS implementation, for example, web method jars for the web method. And it will be getting the data from this data tier and then pass it back to the client. So this is a typical 3-tier application. The data tier can have files. The data can come from files, databases, other systems, and exposing the data as RESTful web service or message-oriented middleware. Since web services are very popular, you can have either SOAP-based web service, which is JAX WS, or RESTful web service, which is JAX RS. And there are a number of frameworks available like Apache CXF, REST-AC, Jersey, and so on. There are a number of tutorials here. You can go through them if you're not familiar with RESTful web services. So basically, you'll have a user interface, which is a web browser, making AJAX calls to the backend service. So you'll have a number of different services like customer service, order management service, product service, and so on. And you can get data as XML, JSON, Atom, RSS feeds, etc. JSON is more popular as its messages are more compact. And once the data is received via the JSON, via the RESTful web service call, it will be rendered on the browser. Nowadays, the applications are very rich internet application. So you'll have rich multiple tabs and the one single page application basically. So multiple tabs, and each tabs and sections will be making different RESTful web service call and getting different data, and they're only rendering that particular section. Next, if you move to the message-oriented middleware, let's expand this. You have a message-oriented middleware, which is or a broker, which could be a web methods, TIBCO, Mule, etc. Then you'll have a producer application or a sender application, and you'll have a receiver application or a consumer application. These two applications don't have to know about each other. Then you will have the broker. So only each one of these applications has to know about the broker. So one application will publish or send message to a topic or a queue, and the listen application will subscribe to either a topic or receive messages from a queue. So they are loosely coupled, and both the applications don't have to be up. So this application can be down, and producer application can still publish message to the queue, and the messages will sit in the queue or can be persisted to the database, and then when these consumer application become available, they will start receiving their messages. Next, you'll have Java Mail for sending emails and simple via Java SMS to send SMS messages. Then there are overnight batch jobs. That's basically for extract, transform, and load. So data will be extracted from one database and then converted to a feed files, loaded to a staging table, and then loaded to another database table. There are a number of different frameworks available. One is a Spring Batch, and the new JE 6 has got JE Batch Jobs framework as well. You can use that. And there are some commercial products like IBM's Data Stage to do ETL operations. Next is there are a number of integration frameworks like Apache Camel, Spring Integration, which support number of different protocols, and they also support the Enterprise Integration Patterns or EIP, which is about 64 to 65 different patterns and best practices to integrate with different systems. So you can Google or check this site for EIP, Enterprise Integration Patterns, for more details. These EIPs, the Apache Camel and Spring Integration support a number of different protocols like HTTP, FTP, JMS, JPA, JMX, LDAP, and many more. So let's expand on this. For example, if you want to create some feed files via your website or something, you can click on the send button from a website, and then you can create using Apache Camel a number of routes. So what the routes does is it can use RESTful web service and extract data out of different databases and systems, and then produce different feeds for feed files, and it can be multi-threaded as well. And these feed files can be then processed by other systems. And you can also use here as a multicast parallel processing. Next, let's move to Enterprise Service Bus. Enterprise Service Bus basically extends the integration frameworks, is more commercial tool with bells and whistles like auditing, logging, and other services provided by it. For example, TIBCO ESB, Web Methods, Mule, Oracle Service Bus, etc. are enterprise service buses. The enterprise service buses provide mediated services and orchestrated services. The mediated services is kind of one-to-one call, so an application will be calling a service here that will be making a simple web service call and getting the data, transforming it, and then sending it back. The orchestrated service is where a single call will end up calling multiple RESTful web services, and also the orchestrated services provide data rollback through kind of compensation based calls. So for example, one particular call from this application will need 3 RESTful web service calls. The ESP will be making the orchestration logic where it will be calling the service one after the other and passing the return value from one service to the other and so on. And for whatever reason, say if the second service failed, you need to roll back the call made from the first service, so it might be making another RESTful service call to compensate or roll back the change. So it will be making, and also it will be doing some data transformation or translation, so that you can have one contract from this application to the ESP, and there will be another contract between the ESP to the other endpoint services. The ESP will be translating the data from one format to another format. And also the orchestration services of the ESP will be doing logging, auditing, services on behalf of the callee. You can also link with the BPM tool, so it can be placed in a queue and then be picked up by a business process management, and then the output will be sent to another queue and they'll be received by the ESP. So ESPs normally support a number of different popular protocols, so you can use messaging, rep service calls, FTPs, and so on. And if you look at it, this is using kind of different hybrid architectures. For example, your application layer here, tier, will be using a typical MVC application, model view controller kind of application based in Java. And then you will have the enterprise service bus using SOA based architecture. And then you will have integration styles with the RESTful web services, and this is a data tier. Then you can have TCP based socket level integration. Not too often you use low level TCP IP level protocol, but there are scenarios where you need to use TCP. For example, you have a system, you're building a system that communicates with a lot of petrol sites. So you might have a low level protocol to communicate with the petrol pumps that might have a quarter-inch VGA monitor, and you will have, once the user swipes the credit card, the details need to be passed across TCP IP to the backend server to be processed with the credit card details, and then from there it might go to the payment gateway, get processed, and then response gets sent back to the petrol sites. There are frameworks like Mina, which is a non-blocking I/O, so which gives you more scalability compared to creating multiple threads. And this Mina uses the event-driven architecture. So event-driven architecture also is a loosely coupled architecture where you will have event producers and event consumers, and you will have event hub, which will have a dispatcher, will be dispatching different events. So for example, here you have event hub here, and you have a JMX console, which is one client, and you will have the other producer, which is a standalone Java application which fire events, and the event hub will be dispatching the events to the listeners. Listeners will be subscribing to different events like a PL event, SL event, and so on, and all the events get subscribed. So this is another loosely coupled architecture, and Mina is based on this event-driven architecture. Then there are other integration styles using RMI, Burlap, and Hessian. They are not very prevalent, but there are instances you need to use them. Then next, let's look at the FIX protocol. FIX stands for Financial Information Exchange Protocol. There are frameworks like QuickFixJ and Cameron Fix, so they talk FIX protocol. FIX protocol is predominantly used for customer market data, market pricing, buying, selling, trades. So anything to do with finance information, you can use a FIX protocol. Here I'm showing a high-level architecture of a trading application. So this trading application uses hybrid architecture. So usually, even though you will have different integration styles and different architecture, a typical enterprise level architecture will have a hybrid combination of all these. Each approach has its own pros and cons, so you need to pick the right architecture depending on the requirements. Here what we have is a standalone web application which is deployed to, say, WebSphere application server. This might be using an MVC framework like Spring MVC or Struts, or even JavaScript based client-side MVC framework like AngularJS. Then you'll have a JBoss application which exposes a number of RESTful web services. So these RESTful web services like placing trade, retrieving contract notes, getting security, share data, and so on. So this web application, when the user clicks on place trade or whatever, then this will be making a RESTful web service call to this JBoss application, which will be another Java JE application as well. So this will be getting the request and will be storing some data into the database via JPA or JDBC. Then you will have a number of interfaces to place orders and into the queue. So we are placing a queue because it will give you high availability, because when you have a share market application, the trading time is only during the business hours, but sometimes the trades can be placed even during off business time. So your requests might be stored and then or placed in the queues, and then when these systems become available, they can be placed onto the stock exchange. So you'll have a request queue and a response queue, and also there's an order status queue where once your share has been fully or partially settled, you'll be getting response back asynchronously, and that can be placed in the settlement queue or order status queue. And then there could be an application that is constantly monitoring the order status queue and asynchronously get the data and then store it into the database. You can also use a number of integration server within webMethods or TIBCO. This will be making a SOAP-based web service, and then the data will be stored into another database. So this is a very high-level, simple trading application showing different components. One is a service provider, then one is like a web, and then you have a message-oriented middleware, and you'll have a fixed protocol there. So the information will be translated from basic message format into kind of fixed router format, and then will be sent through the FIX engine to the stock exchange. So FIX got its own specific format, so that's a responsibility of the FIX router to convert this data and then send it to stock exchange. So what we have seen here is a typical online transaction processing where lots of transactions will be processed and will be stored in the database. So this is a very highly transactional system. It has to be highly scalable, and it has to process a lot of messages per second. So it has to have a good throughput. Let's look at the OLAP. So OLTP is online transaction processing, which is a transactional system, and OLAP is online analytical processing. So with OLAP, the databases will be normally denormalized. The data will be aggregated, and number of years data, the historical data, will be analyzed, and reports will be produced for the management to make critical business decisions. So OLAP stands for Online Analytical Processing. So that is run by the data warehouse systems. Those data warehouse systems normally get aggregated data, and they'll be having multi-dimensional data over a number of years, and they'll be producing valuable reports for the management. So you can see here a lot of the different transactional or operational systems will be OLTP to database, here the ERP, enterprise resource planning system, customer relationship management systems, and then flat files. All these will be processed by the ETL and then passed to the data warehouse systems to produce reports. Now the next approach is called mashups. So there are two types of mashups. One is a server-side mashup and a client-side mashup. In the server-side mashup, you'll be making, from the client browser, you'll be making a call to the backend server. The backend server will be talking to a number of different systems. It could be internal systems as well as external systems. So for example, it can talk to a number of internal systems and then external systems like Amazon Web Service, Google Web Service, and so on, getting the data, translating them, and pass it back to the client browser. In a client-side mashup, basically you will be using AJAX or JavaScript-based calls, and the client browser will be responsible for calling number of internal and external systems. As you all might already know that JavaScript got a restriction to talk to multiple domains. So to overcome that, you need to use JSON-P or CORS. CORS is a more industrial level solution for cross-domain calls from a JavaScript. CORS stands for Cross-Origin Resource Sharing. And basically what CORS does is it makes an options request first and then followed by a get or post or put request. So if I expand on this, so you can see JavaScript and XML HTTP request, and it'll be making calls across to a number of different systems from the client browser itself. So this is a client-side mashup. That's all for this video, and there are a lot of other questions covered at java-success.com. You can find a lot of diagrams, architectural diagrams, and also it covers a lot of beginner level to enterprise or senior level interview questions and answers. And you can click on Open All, that will list all the questions and answers. And also there are a number of tutorials. If you're not familiar with something, it has fixed tutorial, popular frameworks, SQL, JSF, anything from beginner to advanced level. And also, most importantly, it has a lot of job hunting tips, which is a very must. So if you're looking for a job, you need to have good job hunting skills. Hope this website will help you fast track your career, and I'll meet you with another tutorial or video pretty soon. Thank you.